Good day and welcome back. Today we're going to talk about the last topic in this semester, which is the alternating current circuit. At the end of this video, you should be able to explain the concept of the root mean square value and learn how to calculate its value for a sinusoidal case. And then we're going to derive the expression of the current and the power with a given voltage source. And we're going to explain the phase difference between the current and voltage for a pure resistor. First, what is an AC current? It is a current that changes its direction at a certain frequency. We can have a square wave, triangular wave, or the sinusoidal wave, which is the scope of our study in this semester. Sometimes we would like to know what is the power dissipation in an AC circuit. For a complete cycle of a waveform, if we want to calculate the mean of the current to obtain the mean power dissipation, the result would be 0 ampere, which is not true. So to calculate the mean power dissipation, we are going to use the value of the root mean square of the current. The formula of the root mean square is given as the square root of the mean of I square, or the square root of the total I square divided by the number of samples. But the formula is not important. You just need to understand that root mean square of current is a DC current value that dissipates power at the same value as the mean power dissipated by the AC current. For a sinusoidal waveform, the root mean square of current is given as peak current divided by surge2, and this is also the same for the root mean square of the voltage, which is equal to the peak voltage divided by surge2. If you compare these two graphs on the left, these two sources dissipate heat at the same rate, where the power dissipation are the same. Next, we're going to look at the voltage and the current expression in AC circuit. You are given with a sine wave voltage source in a pure resistive circuit. So we have learned about the formula of V equal to IR. So the current is equal to voltage divided by the resistance. Put in the formula of the voltage and you would get I is equal to V0 over R sine omega t, where you can replace the V0 over R as the peak current in the waveform. So from these two equations, we can see that both V and I are in phase. In another word, their phase difference is equal to 0 degree. So both V and I are in phase, which means they change their value together at the same pace. If the voltage increase, the current is also increased and vice versa. Next, we're going to study three types of power in this topic. First is about the instantaneous power, that the power is given as the formula of VI, which we have learned before. It is also can be derived as I square R or the V square over R. Next is about the peak power. So we use the value of the peak current or the peak voltage to calculate its value. And to calculate the mean power, we just use the root mean square value of the current or the voltage to obtain its value. Besides this formula, we also just learned about the root mean square value of a sinusoidal waveform is given as the peak value divided by surge2. So you can substitute the formula of the root mean square into the formula of the peak power and the mean power to obtain another expression for each of them. So the derivations is quite simple. I will leave the formula here for you to do your own self-study. If you have any questions, you can leave it in the comments section. In addition, you also can observe the formula of the peak and the mean power. You can also actually determine the relationship between the peak and the mean power, that the peak power is twice of the mean power. Now we're going to summarize what we have learned by looking at one example in past year in 2019. We are given with 200 ohm resistor connected to a AC voltage which is equal to 250 sine 100 pi t. To obtain the current, we just divide the voltage formula with the R, which is equal to 1.25 sine 100 pi t. And as for the formula of the power or the instantaneous power, it is equal to VI or V square over R or I square R, and it will be equal to 312.5 sine square 100 pi t. So remember that for a pure resistive circuit, V and I are in phase. Their values are changing together at the same pace. Based on these three equations, we can obtain the peak of voltage, current, and power. And then we can use them to obtain the mean value, where the root mean square of voltage is equal to 176.78. Root mean square of current is equal to 0.88 ampere. And as for the mean power, you can just multiply the root mean square of voltage and current, or you can just divide the peak power by 2, which is equal to 156.25 watt. And then we also can draw a graph to represent these three expressions. First is the voltage source, which is a sinusoidal waveform, and then the current with a lower amplitude. And then for the power dissipation, it is a waveform as shown in the slide. So you can see that the power dissipation is always positive all the time. And this indicates that power is always dissipated through the resistor all the time. Besides those peak value, we also can obtain the period of the waveform from the equations. We learn about the angular frequency is equal to 2 pi f and it is equal to 100 pi from the equations. Solving this equation would give us the frequency of the waveform equal to 50 Hertz and the period is equal to 0.02 seconds. So that's conclude my discussion for today. If you have any questions, you can leave it in the comment section below. Also, do leave a like and subscribe my channel. I'll see you in my next video. Thank you.